All right, we're going to be looking at a piece of Hewlett-Packard test equipment. This is the Logic Clip 10528A. You don't see many these days, and this one was the user manual here was printed. It says copyright 1970. This was printed in August of '74. So what is a Logic Clip? Well, let me show it to you. It's in the original box here. I found the box interesting also. It's a Flexitop made right here in San Rafael, California. 123 Carlos. San Carlos. Yeah, Carlos Avenue? Wait, just Carlos. 123 Carlos. By the Shaw Clayton Company. Anyway, this is a Logic Clip. So it is one of those clips that you can go over a 0.3-inch IC, a regular IC. Just clip it right on. And it grabs the pins, makes electrical contact to them, and then it has some LEDs, so it tells you what's going on. 7 volts max, be careful. So you don't want to use it on a CMOS circuit. All right, it's designed for logic level determination on TTL and DTL, up to 16 pins, 5 volts plus or minus 10 volts across any 2 pins at 140 milliamps maximum current. Interesting. Anyway, it even has a flow chart of how this thing works. Connect to pin. Is it a VCC pin? If yes, automatically connect that to the VCC bus. If not, is it a logic high? If it's yes, you activate an LED. If it's an logic open circuit, also turn on the LED. Is it ground? Then connect it to the ground bus. Is it logic low? Well, then don't do anything. So, yeah, it's interesting. I don't know if this actually has an IC in it or it's just a bunch of diodes. It might just be a bunch of diodes. Anyway. Let's see, can we see that? It looks like it's got circuitry in it. I don't know. This says 1 of 16 sections, a decision gate network. It might just be diodes. Anyway, logic level, and yeah, there might be a driver. Maybe it's just diodes and maybe one transistor or something to turn on the LEDs. I don't know. Anyway, that's what it's got inside of it. Does not have a schematic, but we can play with it. So let's play with it with chip of the day. The chip of the day is a 7428. 7428 is a quadruple 2-input positive NOR gate. So these are NOR gates. So if either one of these is high, the output will be low. And if neither one of these is high, if they're both 0, 0, then the output will be high. So let's check that out. All right, here's our chip powered up. Here is our Logic Clip. I guess it doesn't matter which way around you do it. You can do it forward or backwards, doesn't matter. We will clip this on and we get lights on top. Look at that. Let me move the camera over. All right. So 1, 2, 3, 4, 5, 6, 7. Then the 8th one is high because there's nothing there. It's only a 14-pin chip. So the last 2 are high. But we have this sequence here. We have a low, high, high, low, high, high. And then we have a low, because that's the ground pin. Then we have a high, that's the VCC pin. Then we have a low, high, high, low, high, high. All right, so let's take the first one. And right now they're both floating. So it's high, high. TTL, you can float the pins and they're fine. So we have a high, high. Let's ground one of them. And now we have a low, high. We still have a low output. Let's ground the other one. So now we have a high-low, and we still get a low on the output. But if they're both low, then we have a high on the output. So yeah, that's how it's used. back in the day when maybe things weren't quite reliable. You really needed to check this stuff out. Obviously, it doesn't really work when it's running because everything will be a big blur. So it's only for slow signals. I can't say I ever used one at work. I used logic pulsars and I used logic probes, but I don't think I ever used a logic clip. And that's probably why I have it, because it was in my toolbox, never got used, and I ended up taking it home one day. So there you go. All right, that was chip of the day, a 7428. You don't see many of them around. You see a lot of 7432s, which is an OR gate. This is the NOR gate, has the inverted output. And an introduction to the Hewlett-Packard 10528A logic clip. There you go.